I've got two major announcements that I need to make. Let me go and do this one first. I think I told y'all at the first of the term that I have a mild form of leukemia. So I have to see my hematologist every few months. And the trouble is he only sees patients on Tuesday mornings. Okay? And next Tuesday is when my appointment is. Now, when they give me a choice, I always ask for earliest in the morning or last in the morning, because they only see patients in the morning. And they didn't give me a choice this time. They assigned me the time of 10 o'clock next Tuesday. I have to be there for labs at 9 o'clock, which means if I were to come to campus, I'd have to leave by 8:15 to get back to the Kirkland Clinic by 9, parked and everything by 9 o'clock. So I will not be here. Wipe the smile off your face. Okay. Next Tuesday morning until sometime probably into the afternoon. So it's going to wipe out my first class. It'll wipe out this class. It probably is going to wipe out part of my 11 o'clock class. I can deal with them there. It's a real small class. Okay, but these two classes, the first one and this one, are good-sized classes. Now, what I'd love to do is make up the class. The trouble is I only have office hours on Monday, Wednesday afternoon, 3:15 to 5:15, so there's anywhere in that 2-hour frame we could do an hour, 15-minute class, or I can come back on Friday morning and do a class. Will either of those work for anybody? No? Huh? Monday, Wednesday from 3:15 to 5:15, anytime in that window, or Friday morning from 7:45 to any time in the morning on Friday. Okay, so anybody, any of those times work for anybody? What I'll do is record the class, and and everybody else can listen to it later. If that won't work for anybody, any of those times, can you get your name, please? I got it. Sorry. Yeah, you are. Okay. I was just saying, next Tuesday I've got a doctor's appointment at 10 o'clock, which means I have to be there for labs at 9 o'clock, which means I won't be able to come in at all that morning. I'll get back as soon as I can. Let me start this over. Okay. Starting over, and Justin's been in my class before, so he, I think, probably remembers this. I have a doctor's appointment next Tuesday at 10 o'clock. So this class wiped out, okay, because I have to be there by 9 o'clock for labs, and it won't be through even if he sees me at 10, and I'm through by 10:15. I won't be here back on campus before 11 probably. So this class is wiped slip. Hopefully I'll be back for my 11 o'clock class. But that's going to be tight. So we're trying to find, does anyone available either Monday, Wednesday afternoon, anytime between 3:15 and 5:15, or Friday morning, 7:45 to 11:45.
What day?
Monday, Wednesday, 3:15 to 5:15, or Friday morning, 7:45 to 11:45. Anyone available any of those times? Okay. What's that? Which would you rather have? Friday morning? Okay. I've got to check, but they originally said we have a meeting coming up this Friday, so it would probably have to be next Friday. Is that okay? Okay. Huh? Okay. So what we'll do, we'll have class today and Thursday. We won't have class on Tuesday, but we will have class Thursday and Friday. What time on Friday is better for you? It's the same time, 9:30? Okay. So what we'll do is have class this week, Tuesday, Thursday, just as normal. But next week, not on Tuesday, but have Thursday, Friday, 9:30 to 10:45. Okay? and we'll do that and make up the class that way. Now, for those who can't be here, I understand if you can't, you'll be able to catch it on YouTube video. Okay, I'll post that Friday as soon as class is over. It takes a while to process, and as soon as it gets processed, I'll post it out there. So hopefully it'll be Friday afternoon, but if not, 9:30. Okay, what's your name, please? Huh? Okay. Jeremy. All right, let me go over it again. I've got a doctor's appointment next Tuesday, okay? 10 o'clock in the morning, but I have to be there for labs at 9. So that's going to wipe out the whole class, okay? Actually, it wipes out my morning class too, because even if I were to come to campus, I'd have to leave by 8:15 to get back to Kirkland Clinic by 9 o'clock to get parked and everything to be there in time for my lab. So I won't be on campus next Tuesday morning until 11-ish, maybe even a little after 11, okay? 11 at the earliest. So this class is wiped out. So what we talked about possible times, and the only time we came up with was not this Friday, but next Friday from 9:30 until 10:45, we'll have a makeup class. If you can't be here, it'll be on YouTube video. So you'll just have to watch it there. I would have said this Friday, I would have liked to have done it, but they told us at our meetings at the beginning of term that we had another meeting coming up this Friday, and we haven't set a time for it yet, so I don't know what time it is, so I can't set it for now. So we'll have it next Friday. So this week we'll have class Tuesday and Thursday, 9:30. Next week, not Tuesday, but Thursday and Friday at 9:30. And we'll pick up and go from there. Okay. I'll try to remind you every class of that. That's one. Here's the second, okay? I don't know if any of you know Miss Geraci, who teaches on the Birmingham campus. She is the math team coach, but we all help out as much as we can. There is a competition coming up the first Friday, I think it is, of October, okay? And she's trying to recruit people to be on the math team. It's a really fun time. It's no pressure. It's just, it helps your math skills, but it also is a good time to be with other classmates and stuff doing it. And she really wants to recruit students. And y'all are prime candidates for that. Any of you interested in being on the math team? It is a fun experience. The team last year, we just had never had one before. What's that? They do get to travel some. The first meet, I think, is in Tuscaloosa at Shelton. So you get to travel there. We'll arrange transportation. Probably, I can't say what all. Probably meals go with it and stuff like this. I can't say for sure, but we'll do whatever we can to help you as much as we can. That's why, So anyway, if you want practice sessions on this campus, again, the time I'm available to give them are Monday, Wednesday afternoon, 3:15 to 5:15. If anyone wants to practice, they're fun times. We work through problems that they've used before, so you get a feel for what kind of problems they are. And it's really, we had a really good time with it last year, and it promises to be that. It really, and it helps you in math. I think for all the math you ever take, it's just a really good time, but it's also fun. So, can I give her any of your names, or any of you interested? Pardon me? Think about it. Okay. If you want to contact her in person or by email, it's N. Geraci, Jaraaysi. Write it down. Let me go on and get this set up. All right. Let me get my pen activated. Jar. I can't spell. at lawsonstate.edu. Okay. In Geraci, JaraysI at lawsonstate.edu. Please, she really is looking for students to participate. You don't have to go to, she'll have times on the Birmingham campus when they're having practice sessions. She said she can come out here if that's more convenient for you, especially times that I can't do it, like Tuesday and Thursday afternoon. But I can do it Monday, Wednesday afternoon after 3:15. And we could do Friday mornings. I can go to either campus. I'm usually there on Friday, but I'll come here if I need to be here. So we'll have the practice sessions that you need so you can feel good and confident. Last year, with basically no experience at it whatsoever, the team, I think, came in like third or fourth, in the competition with, and just really surprised themselves, and I think everybody else too. So it was a real good time. Okay, and there may be other competitions coming too. That's the first that I've heard about. So let me know or let her know. And if you do want practices on this Monday, Wednesday afternoon, 3:15, anytime between 3:15 and 5:15, for an hour, for a half hour, for an hour and a half, for 2 hours, whatever you want, we'll find a room. I can't say for sure this one will be available. Either this room or 257 will be available, and we'll have it in one of those. And I'll record those on YouTube as well, so that you can, if you can't make one, you can still listen to the others. Okay? So let me know or let her know. All right. Now, any questions, anything we've done so far? Now, remember last time we found, let me just do a slide back. We did these angles. We were able to figure out what the sine, cosine, tangent, cotangent, secant, and cosecant are these special angles. 0, pi fourths, pi halves, 3/4 pi, pi, 5/4 pi, 3/2 pi, 7/4 pi, or 2 pi. And go around and around either direction that you go, because we knew the values there. Okay? We can do something very similar for another set of angles, or they like to call them real numbers, and that are these. Okay? Now, let's just take this a little slower. What we've done, get your name, please. Mike, got it. All right. Two things. Number one, I've got a doctor's appointment next Tuesday, so we will not have class next Tuesday. However, we're going to make up that class next Friday, not this Friday, but the following Friday, 9:30 that morning here in this room. Okay? If you can't be here, it'll be on YouTube, just like all the classes are on YouTube. Number two, Ms. Geraci on the Birmingham campus is the coach for the math team, but we all help. So if you are at all interested in being on the math team, it's a fun time, and it actually pretty helpful to you in math too, I think. And we're going to start practices soon. I can do practices on Monday, Wednesday afternoon, anytime after 3:15 to 5:15. So if you're interested and want to do it, see her, contact her, let her know, but see me too. And if you want to have a practice sessions on either Monday, Wednesday, or both, 3:15 to 5:15, I'm available to do that.
And you said you won't be here next Tuesday?
Next Tuesday, I've got the doctor's appointment.
Yes, sir. So with the class council or somebody will be
no one will be here, but we'll make up the class next Friday.
Oh, that's Friday.
Yeah.
Okay, I'm with you.
Okay. Yeah. And if you can't be here, it'll still be on YouTube video. Okay. All right. Now, what we're going to do is look at some of these angles, and they just threw some numbers out here. How did they get these angles, these numbers? What I would like you to do is just look at this. Now, what they've done, they've taken the unit circle here and split it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 equal pieces. Okay? And how many radians is around the unit circle? 2 pi radians. Okay? And you divide that by 12 equal pieces, and what do you get? Pi 6. Okay. Now, I don't know if you all are familiar with pi 6 very much or not, but I know you know something about pi thirds. So let's take, rather than pi 6, pi thirds. And it doesn't really matter where you do this. This is a unit circle. Let's just take this wedge here from minus pi 6 down here to pi 6 there, and this is pi thirds, right? That angle there is pi thirds. So this is pi 6 and that's pi 6. That's pi thirds. Now, does anyone know anything about a triangle whose angle is pi thirds, and by the way, whose radius is 1 and 1? Remember, this is a unit circle, radius 1. Okay? I'm going to do something. I'm going to connect these two dots here. Okay? Now, if this is pi thirds, and it is, pi 6, okay, and these two sides are the same, that means these two angles are the same, aren't they? This side and this side are the same, the opposite angles have to be the same too, right? Does that make sense geometrically? Okay. So if these two angles are the same and that one's pi thirds, let's just write that as a sentence here. Pi thirds plus 2, what do you want to name those angles? I don't care. Pick something. Say again? Did I hear beta?
Yeah, beta.
Okay. But see, since they're the same, let's make them both beta, right? They've got to be the same, right? So plus 2 beta is equal to what? What's the sum of the 3 angles of a triangle? What is the sum of the 3 angles of a triangle? Any triangle. Y'all don't know this from geometry? Given a triangle, what's the sum of the 3 angles? 180 degrees, we're thinking in terms of pi. What's that? Pi, okay? So that sum is pi, right? Everybody agree with that? And would you say that pi is the same as 3/3 pi? Would that be fair? Yeah, okay. That's the same as pi, right? Now we can subtract pi thirds, or 1/3 pi, from both sides, can't we? That's legal, right, in most states? Okay? So this gives us 2 beta is equal to how much? 2 pi over 3. So guess what beta is equal to? Pi thirds also. So in other words, both of these two angles are pi thirds. That angle's pi thirds, that's pi thirds, that's pi thirds. What do we call? Can I get your name, please?
Taiwan.
Taiwan, okay. What do we call a triangle that all 3 angles are the same? And here's the Zarya. What do we call a triangle? Well, let's see. Let's back off a minute. Okay? If this is pi thirds, that's pi thirds, and that's pi thirds, that means the 3 sides have to be equal. If the 3 angles are equal, the 3 sides have to be equal, right? We know these 2 sides are both 1, because that's a unit circle, right? That means this side right here has to be 1. So what do we call a triangle whose all equilateral triangle, which is also equal angular triangle too, but it's an equilateral triangle. Okay, now you just told me that this length here was 1. And this bisects it exactly, so what would be the y value of this point here? If that's 1, that would be 1/2, and this would be negative 1/2, wouldn't it? Okay, so we now know that the y value of that point right there is 1/2. Do you know what the x value of that point is? Remind you, that's a unit circle. What's true about every unit circle? I know it was a week ago. It was awful long time. We had a holiday in between, so wiped the Etch-a-Sketch, cleaned it. No, we didn't do that, did we? What's true about every unit circle? Okay. Turn your pages back to... Oh, yes! Is equal to 1. Okay? And we know the y is 1/2, right? So x squared plus 1/2 squared is equal to 1. Well, what's 1/2 squared? Say again? 1/2 squared. Squaring it, not doubling it, squaring it. 1/4, okay. 1 is how many fourths? 4/4. So I could write that as 4/4, couldn't I? Right? Okay. And now we could do what? We're trying to solve for x. What would you do next? Subtract 1/4 from both sides. Okay, so you got x squared is equal to 4/4 minus 1/4 is? Say again? 3/4. But I don't care what x squared is. I want to know what x is. What would that be? Say again? Take the square root of both sides, and what would that give us? Plus or minus the square root of 3. What's the square root of 4? 2. Square root of 3/2. Now, I already said that I knew this y value up here was plus 1/2. This one has to be a minus 1/2. Well, now we know that the x values are plus square root of 3/2. Or if we did it on the other side here, it would be minus square root of 3/2 if we happen to be over here. So now we know the x value. Root 3/2, 1/2, or minus, or root 3/2 minus 1/2. And we could go over here and say minus root 3/2, 1/2, or minus root 3/2 minus 1/2. That would be the same. And guess what? What if we had done that not for this pi-thirds angle, but for that pi-thirds angle? Be the same thing, only now your x value would be plus or minus 1/2, and your y value would be plus or minus square root of 3/2. Guess what? We've got every one of those angles now. When you do it by pi-thirds, pi-6, this becomes root 3/2, 1/2. That becomes 1/2 root 3/2. 0, 1. This is 1, 0 down here. And here is minus 1/2 positive root 3/2, minus root 3/2 positive 1/2, minus 1, 0, minus root 3/2 minus 1/2, minus 1/2, minus root 3/2, minus, yeah. You got the idea, right? You got every one of those x, y values all the way around the circle with angles of pi-6 to pi-thirds. Okay? So we know a bunch more. Okay? Here are the angles. 0, pi-6, pi-thirds, pi-halves, 2/3 pi, 5/6 pi, pi, 7/6 pi, 4/3 pi, 3/2 pi, 5/3 pi, or 11/6 pi, and then 2 pi is back here in the same place. Okay? And you could do negatives too, minus pi/6, minus pi/3, minus pi/2. You can go around this way with negative angles. You can keep going round and around and just keep adding them to it. But those are going to be your x and y values. And if you know the x and y values, what do you also know? I know it was a week ago, long time. You know the x and y values, but if you know those for your angles, what do you also know? What's the title of this? The trig functions. What's the sign? Say again? Oh, this is a long time ago, wasn't it? Huh? Okay, that's what they are. What is the sign of any given angle? Okay, yeah, you think the y value. On the unit circle, it's the y value. So for x equal, for the angle theta, or whatever you want to call it, beta, of pi/6, your sine is 1/2. Your cosine is the x value, root 3/2. What's the tangent? Y over x. The halves we have 1/√3, which would be square root of 3/3. And then if you did cotangent, reciprocal of that, secant reciprocal of cosine, and cosecant. Or you can go back to your y. Let's go back to those. The cotangent would be x over y. The secant would be 1/x, and the cosecant would be 1/y. So you know every one of them. If you know the ordered pair, you know the trig functions, right? Every one of those, you know right now. Okay? Now, if you want to make a copy of this and carry it with you, certainly not a bad thing to do. Because these are our favorite angles. Those right there, plus the ones we did last time, which were 0, pi quarters, pi halves, 3/4 pi, pi, 5/4 pi, 3/2 pi, 7/4 pi, and okay. We knew what those were. Remember those two, right? Square root of 2/2, plus or minus everything. These are the other. Now, here's where, oh man. They're backing up and doing what we did when we gave the circle, and this is for the pi quarters. Because on the quarter pies, you have the identity function. Y is equal to x, or y is equal to minus x, depending on which one of the diagonals you do. Let's do y is equal to x, and then this is exactly what we did before, because x squared plus y squared is equal to 1, unit circle. That means if y is equal to x, then that would be x squared plus x squared is equal to 1, 2x squared is equal to 1, x squared is equal to 1/2, x equal plus or minus square root of 2/2. We did that last time with that one. And so for any point on your diagonal, then it's going to be, well, the first quadrant, x equals square root of 2/2, y is equal square root of 2, because it's x equals y. Over here, x equals minus square root of 2/2. This is positive square root of 2/2. Here's minus minus, here's plus minus. But all square root of 2/2 for the quarter pies. For the 6 pies, I guess they're going to show that now. Yeah, they do this. They don't carry it out, but they just show it to you here. It's the one we just did, and I showed you how you got this. 1/6 pi is 3/2. 1/2. 1/3 pi is 1/2 root 3/2, and pi is half pi is 0.1. So you go all the way around the unit circle that way. Okay. Now, let's go back I'm going to do one more thing the book doesn't do, but to me, I find it a handy little thing to remember. Let me draw in my quarter pies, okay? And this would be square root of 2 over 2, square root of 2 over 2. Okay, you could do it here, you could do it here, you could do it here, and you could do it here. Okay, I just want you to observe this. This is just a handy little thing that may help you remember. If you remember those angles, pi 6, pi quarters, pi thirds, and pi halves. Of course, you start with 0. Okay? Let's look at the signs of each of those angles. The first one is 0. The next one is 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Right? That's the sign of each of those angles. Those easy angles. Pi 6, pi quarters, pi thirds, pi halves. Think of it this way. Square root of 0 over 0. Square root of 0 over 2. Square root of 1 over 2, which is 1/2. Square root of 2 over 2, which is that one. Square root of 3 over 2. And square root of 4 over 2. What's square root of 4? 2. 2 over 2 is 1. So your y values for those are square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. And guess what? Going down the other way, the x values coming and going backwards, 0 over 2, 1 over 2, square root of 2, square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. So, hey, almost without thinking about it, you can write every one of those down. And then for the other quadrants, just put in the plus or minus signs in the right place. And you got them knocked. You got them knocked, okay? So you hardly even have to think about them, okay? But remember, sign is always on the unit circle. You told me before, it's still true. Sign is y. I can't draw a y real well with my fingers, okay? Cosine is x. Tangent is y over x. Cotangent is x over y. Secant is 1 over x. Cosecant is 1 over y. You know every trig function. If you know the ordered pairs, which I just showed you an easy way to remember them, you know the trig functions. Every one of them. Okay? So that's what example 1 is going to have you do. Evaluate the 6 trigonometric functions at each real number. T is equal to pi 6. Okay? The first thing I would do is identify the point that's at pi 6. Ordered pair. Plus the ordered pair at pi 6. Say again? Square root of 3 over 2 is the x value, and 1/2 the y value. So now you can just write down what your trig functions are. What is sine of pi 6? 1/2. What is cosine of pi 6? Square root of 3 over 2. What is the tangent of pi 6? Now here, folks, let me give you another. If you write them down vertically like this, then just do sine over cosine. That works, right? It's x, it's y over x. But if you do that, the 2's will multiply the numerator and denominator by 2. 2 over 2 is 1. That's fine. You get 1 over root 3. But a lot of people don't like radicals in the denominator, so how would you rationalize that denominator? Anyone remember how? Say again? Multiply numerator and denominator by root 3. So that gives you root 3 over 3. Okay? Now, cotangent of pi 6 is just the reciprocal of tangent. And rather than using this form, use this form. What does that give you? 3. Root 3 over 1 is root 3, right? Is this too much of a mystery, or is it okay?
Can you repeat that, what we did for
Cotangent? Okay. Cotangent is x over y, right? This is y over x, right? And it's 1/3, so x over y is reciprocal of that. So just flip this over and you get root 3. Right? Okay. How about secant of pi 6? What would that be? Yeah, get out of there. Okay. Another time out here. Well, no, okay. Remember, it's, what is secant? Get 1 over x. Well, here's your x right here, root 3 over 2. So that's going to be reciprocal of that, 2 over root 3. But if you don't like having radicals in the denominator, what would that be? Multiply numerator and denominator by root 3 and get 2 root 3 over 3. Yes? What's that? Cosecant is. Secant is reciprocal of cosine. Okay? That's why the book lists, when they did it, they said sine, cosecant, cosine, secant. Yeah, they wrote them that way because then they followed them by the reciprocals. I like to do sine, cosine, tangent, and then down here do reciprocal, cotangent, secant, cosecant. You know, sort of make a complete circle there. Unit circle, you get back where you started. So there's secant, which is 1 over cosine. And then cosecant of pi 6 would be what? Second? 2. It would be the reciprocal of sine. There you have it. Okay? You can get the ordered pair, and you can by that little rule that we did before. Once you get the ordered pair, you have all the sine, all 6 frequencies by the relationship. Sine is the y value, cosine is the x value, tangent is y over x, cotangent is the reciprocal of that, secant is the reciprocal of cosine, x over y, x over 1 over x, and cosecant is reciprocal of sine, 1 over y. It's that easy to do. Okay? Now, let's move to this one. What is your ordered pair that's represented by the t equal 5/4 pi? Thing you ask yourself is, where are you, Ewaldo? Where? Yeah, what quadrant? Third quadrant, which means x and y are both negative, okay? And you're on your quarter pies, and what are your quarter pies? Those coordinates always. Root 2 over 2, so just fill it in, root 2 over 2, root 2 over 2. It's that easy to do. Figure out where you are, what your signs are going to be, and then fill in the function values there, right? All right, now, that means, what is sine of 5/4 pi? What is sine? Y value. So it's negative root 2 over 2. What's the cosine? It's also negative root 2 over 2 because it's the x value. Negative root 2 over 2. What's the tangent of 5/4 pi? It's just the ratio of those two. Y over x. Sine was y, cosine's x. Take the ratio there. Negative divided by negative is positive. And root 2 over 2 over root 2 over 2 is y. How about cotangent of 5/4 pi? It's 1 because it's x over y. Do the same thing, it's 1. Secant of 5/4 pi. Now here, okay, first give me the SIGN sign of it. This, the SIGN sign, the plus or minus, which is minus. It's the same as cosine, right? So it's going to be minus. Now, how did we get that root 2 over 2? Do you remember way back when we did the math on it? Right here? Oh, they don't show it, do they? They sort of do. When you said x squared is equal to 1/2, what's the next thing we did? Take the square root and you had 1 over root 2. But they don't like radicals in the denominator, so that's the same as root 2 over 2, plus or minus, okay? Well, remember that was 1 over root 2, so if you did the reciprocal of that, what is it? Root 2, exactly. Okay, so we'll go here, and the secant will be negative root 2. And how about cosecant of 5 pi fourths? It's negative root 2 too, because cosine and sine are the same, so secant and cosecant have to be the same. Man, this is supposed to be hard, isn't it? I wish I could make it hard. I haven't figured out a way to make it harder. It's just too simple, isn't it? How about t of pi? Where are we, Waldo? Where are we when t is equal to pi? What point? Second? Second? What'd you say? Negative 1, 0. Is that what I heard? I believe she's right, isn't she? Okay. Okay, so then, can we give what the sign of pi is? 0. It's the y value. How about cosine of pi? Is it dot? Okay. Oh, by the way, here's one more thing I forgot to ask. Last week, did someone leave an umbrella in here? One that was found here late in the day. No one? Okay. It's up here if you find someone who lost one. Okay, because you weren't here when I said it earlier, let me say it now. I don't want you to show up next week, though. If you listened to this, you would have heard it. Next Tuesday, 1 week from today, I have a doctor's appointment, 10 o'clock. I have to be there for labs at 9. Guess what? Wipes out the whole class. Actually, it wipes out my morning class too, but 8 o'clock class, but that's beside the point. Okay, so we talked it over as a class, and we can make up the class by next Friday, not this Friday. I would love to do it this Friday, but I have a meeting, I think, on the Birmingham campus this Friday, so I can't do it then. But next Friday, same time, 9:30. So this week we have Tuesday and Thursday class here at 9:30, and then next week, not Tuesday, but Thursday and Friday, we'll be here at 9:30. Okay, so next Friday we'll have class not Tuesday but Friday. So if you can't be here, I know not everybody could make it. It'll be on YouTube, so you can watch it later in the afternoon. All right, we're doing example 1 on page 274. This is section 4.2. And here we're doing the C part. We identified the ordered pair represented where t is equal to pi, and that would be at negative 1, 0. We identified the sine of pi to be 0. What's the cosine of pi? Say again? Negative 1. How about the tangent of pi? That would be 0 over negative 1, which would be 0. How about the cotangent of pi? Say that again. Say it one more time. Oh, wait a minute. It's what? It's y over x, which is, x over y, which is Negative 1 over 0, which is undefined. You cannot do it. You cannot take the cosine, cotangent of pi. Undefined. Okay? How about secant of pi? What is secant? Negative 1 also. It's 1 over your x value. Well, 1 over negative 1 is negative 1. So that's the x value. 1 over the x value. How about cosecant of pi? What was it? Undefined, because it's 1 over your y value, and y is 0, undefined. Got it? Okay. Let's move to t equal negative pi thirds. I'm going to do it over here so I have more room. First, you tell me, where are you, Waldo? Say again? I can't hear. Okay, you're in the fourth quadrant, and can you tell me about the fourth quadrant? X is positive, y is negative. Okay, we got the signs right, SIGN signs. How about the numbers to match? Square root of 3 over 2 is which? Second? The x value? Okay, you're right. Square root of 3 over... No, you're not, are you? Let's draw a picture. Yeah. Okay, I don't have much room here to draw pictures. Minus pi thirds. Minus pi sixths, that x value would be square root of 3 over 2. Minus pi thirds, that would be 1/2. Right? Aren't we minus pi thirds? So that would be, the x value is 1/2. Right? Am I doing it right? And the y is minus root 3 over 2, right? Are we right? Are we at the right place there? Okay. Now, what would be the sign of negative pi thirds? Sign of negative pi thirds. Goodness gracious, this thing is a pain in the neck. Say again? Negative root 3 over 2, right? It's your y value. What's your cosine of negative pi thirds? What's your cosine? 1/2. Yeah, it's your x value. Okay. What is the tangent of negative pi thirds? Negative the square root of 3. Because you see, you just divide the others. Y over x. Okay. How about the cotangent of negative pi thirds? Anyone? Negative, I'll buy that. Okay, negative 1 over root 3, right? Which, if you want to rationalize the denominator, becomes negative root 3 over 3. Does everybody see that? Do I need to work that out? Does everybody see where that comes from? Okay. How about secant of negative pi thirds? What would that be? Two. 1 over x, where cosine was x, 1 over x would be 1 over cosine. That would be 2. And finally, cosecant of negative pi thirds negative say again 2 over root 3, which if you don't like radicals in the denominator, that would be negative 2 root 3 over 3. That's a pretty ugly 3, isn't it? Okay, let me see if I can clean that up a little bit. Okay. If I get too much written on a page, everything slows down here, and I've got a lot written on this page. Okay. All right. Whew. See them? The key here, find out where you are, Waldo. You know, find out what point represents that real number t. Okay, what ordered pair. If you get the ordered pair right, you basically ought to get all your trig functions right. Right? Now, just a few things to note. The first one here is in which quadrant? What's true about the first quadrant? Both are positive. That means everything's positive. All your trig functions are positive because your x's, your y's, everything's positive in the first quadrant. So all your trig functions have to be positive. And then we have one in the third and one in the fourth quadrant. We didn't have one in the second quadrant. But what do you notice there? Third and fourth quadrant. You have 2 of them positive and 4 negatives. That's true in the second, third, and fourth quadrant. The 2 that are always the same sign, okay, 2 that are positive, are always the reciprocals of each other. All right? Y over x and x over y. X and 1 over x. Those are the reciprocals of each other. They're always the same sign, positive. The others and the reciprocals are also the same sign, but all the other 4 are negative. Second quadrant, it would be cosine and sine and cosecant would be positive because the y value is still positive, the x is negative, so these would be positive and these 4 would be negative. Just a little bit of help on the signs there, SIGN signs. First quadrant, all 6 are positive. All 3 of the others, quadrants, 2 positive, 4 negatives. Okay? The 2 that are positive are the ones, are reciprocals of each other. And the ones that are negative, are the other 4. And by the way, all the reciprocals are always the same signs. Okay, does that make sense? That's how we did it. Let's see how they did it. Okay? Any questions before I erase these? All right. So let's start with t equal pi 6. First thing you do, figure out where you are. When t is pi 6, you're at 3/4, square root of 3 over 2 on the x, 1/2 on the y. So that's where you are. Once you know that, you know all the trig functions. Right? Because your sine is the 1/2, sine is the y value, it's 1/2. Cosine is the x value, so it's root 3 over 3. Tangent is the y over x, which is sine over cosine, which is just due to the division there, 1 over root 3, which, well, they do 1/2 over root 3 over 2, but you can multiply the numerator and denominator, that'd be 1 over root 3. If you don't like having radicals in the denominator, that is root 3 over 3. Okay? Any questions on that? All right. Then the cotangent is x over y. Oh, they start with cosecant. Why do they do that? If you're doing cosecant, do it over there. So it's 1 over y, which is going to come out being 2. 1 over 1/2, which is 2. Okay? Then they do secant. really weird. 1 over x, which is 1 over root 3 over 2, which is 2 over root 3, which becomes 2 root 3 over 3. 2 over root 3, which is 2 root 3 over 3 if you don't like having radicals in the denominator. And then finally, cotangent is x over y, which is root 3 over 2 over 1/2. Just flip those. It is root 3. Make sense? All positive. Yeah. Question? Oh, okay. Good deal. All right. The B one, when t is equal to 5/4 pi. Figure out where you are. 1/4 pi, 3/4 pi, 3/4 pi, 4/4 pi, 5/4 pi. Down here, the third quadrant, and you're exactly bisecting that quadrant, so your values are root 2 over 2, root 2 over 2, but in the third quadrant, they're both negative. So there you have it. Negative root 2 over 2, negative root 2 over 2. And guess what? Your sine of 5/4 pi is your y value, which is negative root 2 over 2. Your cosine of the 5/4 pi is your x value, which is negative root 2 over 2. Your tangent of 5/4 pi will be the y over the x. They're the same number, so that's just going to be negative root 2 over 2 or negative root 2 over 2, which is 1. Okay. Now, I would do cotangent next. They do cosecant next, which is 1 over y. And if you remember, it's a minus sign because your sign is minus, and it's minus root 2. Minus 2 over root 2, which if you rationalize that, or if you remembered where you got it from, it was 1 over root 2, that would just be minus root 2. Okay. Secant is going to be reciprocal of x, 1 over x, which is going to be, again, negative 1 over negative root 2. Your cotangent x, which is the last one, is your x over y, which was negative root 2 over 2, or negative root 2 over 2, which is still 1, positive 1. Any question? 5/4 pi. C part was t is equal to pi, okay? And there you're around that negative 1, 0. On the unit circle, you're at negative 1, 0. So your sine is your y value, 0. Your cosine is your x value, which is negative 1. Your tangent is the y over x, which would be 0 over negative 1, which is 0. But your cotangent is 1 over your 0, which is undefined. Actually, it should be negative 1 over 0, but it doesn't matter, it's still undefined. I'll do it cotangent. Cosecant is 1 over y, which is undefined, 1 over 0. Secant is a pi, 1 over x, which would be 1 over negative 1, which is negative 1, and then your cotangent is x over y, which is undefined. All right. And then when you're at negative pi thirds, the t is negative pi thirds. What does the negative tell you? T is negative. Go clockwise. And you go clockwise 1 pi thirds. Well, pi 6 would be the little angle, pi thirds would be the bigger angle, not quite the pi halves yet. So negative pi thirds would be down here. That corresponds to the point x equals 1/2, y is equal to negative square root of 3 over 2. Okay? Once you have the ordered pair, you got the trig functions. Just a little bit of work, but not bad. Sine is the y value, negative 3 square root of 3 over 2. The cosine is the x value, 1/2. The tangent is the y over x, just put y over x, that would be negative root 3 over 1. Negative root 3 over 2 over 1/2, that would be negative root 3. Now, I would do tangent next, cotangent next, just because it would be easy. They do cosecant, which is 1 over y, and that would be negative 2 over root 3, which you could write as negative 2 root 3 over 3. Secant would be of negative pi thirds would be 1 over x, which would be 1 over 1/2, which is 2. And the cotangent is of negative pi thirds, x over y, which is 1/2 over negative root 3 over 2, which is negative 1 over root 3, which is negative root 3 over 3. However you want to write it. Make sense? All right. Reminder, there is a checkpoint. Do the checkpoints. As soon as you can after class, go back and do those while it's fresh on your mind and try to get those done. If you have a problem doing them, LarsonPrecalculus.com has the audio video solutions for the checkpoints. So now we're going to talk about domain and period of the sine and the cosine. I think we remember what domain is, right? What are the input values that you can put for sine and cosine? Input values. If you had sine of t, what t values could you put in there? Negative infinity, infinity. All real numbers you can put in there. Okay? Cosine? Same thing. Negative infinity, positive infinity. Everyone works. Now, we haven't talked about period yet, but we really observed the period, but we haven't talked about it yet. So let's do that. The domain of the sine and the cosine functions, set of all real numbers. That's where we usually start our domains to be. Set of all real numbers unless there's something to restrict it, right? That's what we did in pre-calculus algebra. Always assume the domain all real numbers unless something wipes it out. Sine and cosine, nothing wipes it out. They're defined forever, okay? Now, what's the range, though, of your sine and cosine function? That's the y value. It goes from -1 to 1, okay? It's the y values go from -1 to 1. Okay, now here's the problem, folks. Usually when we talk about a function, we're doing y as a function of x. That's not what we're talking about here. Here we're doing the sine of t, okay? Your input here are the t values. Where t starts at 0, goes to pi halves, negative pi, pi, 3 halves, pi, 2 pi. The t's are what your inputs are. Not your x, not your y, okay? When you put in the t, then you get an ordered pair. Your sine function will be your y value, which is just like what we had before. That would be your output. So your output here is from -1 to 1. That's what it is. But for the cosine function, your output is the x. It's not the input is the x. Your input's the t. The output is the x. And that goes from -1 to 1. So you see the ranges of these functions. And this is a little bit different from what we did. Because guess what? That would not be a function on the xy plane. Why? It fails the vertical line test. So what your input here is your t, and that gives you 1 and only 1 x and 1 and only 1 y. Your output is your y for the sine and your x for the cosine. Okay? And both of those have domains of -1 to 1. So this isn't the graph of the sine and cosine. That's the graph of the unit circle. Sine and cosine, we're going to do the graphs just a little bit later, like in section 4.5, I think it is, where we do the graphs of these. I wish we did it now. It would help make more sense. So, by definition, you notice your independent variable is t, not x. Your dependent variable is y for the sine, x for the cosine. Okay? And because the xy ordered pair is on the unit circle, you know that the y's can only go between plus or minus 1, so that's your sine ranges, and your x can go from plus or minus 1, and that's your x ranges. That's your cosine ranges. The values of sine and cosine in the range between, also range between minus 1 and 1. Okay. That's always true. Minus 1 is always less than or equal to sine of anything, and that's less than or equal to 1. Same thing with cosine. So those are your domains and ranges. Domains, all real numbers. That's the t values. Ranges plus or minus 1 for each sine and cosine. Okay. Now, what we already said about coterminal angles. Remember, you can go around and around and around and around and around the unit circle as many times as you want. You're going to repeat the same pattern that you did one time around. After that, you repeat the pattern again and again and again. So therefore, we call one pattern to be one period. Okay, that's what we're getting right here. If you went around the other way, there are various values here, but then when you get here, it starts repeating itself. So, anytime the t's, those input values, are 2 pi more than the previous one, or less than the previous one. Here, t is equal to 0, but then t is equal to 2 pi, 4 pi, 6 pi, 8 pi, anything increased by 2 pi. If this is pi quarters here, then you add another 2 pi to it, and you're at 9 quarters pi. Add another 2 pi to it, and you're at 13 quarters pi, okay? So every time you go around, you're adding 2 pi. Here, you're at pi halves, go around one more time, you're at 5 halves pi. Go around again, you're at 7 halves pi. You just keep going, increasing it by 2 pi. I don't think I said that right. 5 quarters pi, 9 quarters pi. Okay? If you start at 3 quarters pi, go around 2 pi more, which would be 8 quarters pi, that'd be 11 quarters pi, plus another 8 would be 19 quarters pi. Every time you go around 2 pi, you're back at the same value, and they repeat themselves. At pi, 3 pi, 5 pi, 7 pi, 9 pi, many times as you want to. 5 quarters pi plus 8 quarters pi would be 13 quarters pi, 23 quarters pi. You go around 2 pi every time. 3 halves pi, go around 2 pi, and you're at 4 quarters. That'd be 7 quarters pi, 11 quarters pi, 15 quarters pi. Same thing. Every time around, you add 2 pi to it. So guess what? You repeat the same pattern every 2 pi for sine and for cosine. Okay? Because you're at the same point with the same coordinates every time. So the values of sine of t and sine of t plus 2 pi, cosine of t and cosine of t plus 2 pi correspond. Those are the same values because the x value is the same, the y value is the same. Similar results can be obtained for repeated revolutions, positive or negative, anytime you go 2 pi around plus or minus on the unit circle you do. So here's what you get. Sine of t plus 2 pi n, where n is any integer, 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, yeah. Any integer you put in there is going to be the same as sine t. Cosine of t plus 2n pi is going to be the same as cosine of t. For any integer, not any number t, but any integer t, and any real number t. Any integer n and every real number t. The functions that behave in such a repetitive or cyclic manner are called periodic functions. That is a key. I'm guessing most of you are going to take physics at some point, right? If you take physics, you'll learn about simple harmonic motion, things that repeat themselves over and over and over again, represented by periodic functions, sine and cosine functions, basically. So they're called repetitive or cyclic, called periodic functions. They repeat themselves every period. Therefore, the period is 2 pi. For sine and for cosine, the period is 2 pi. That's where it starts repeating itself. So here's a definition of a periodic function. A function is periodic when there exists some positive real number c such that f of t plus c is always the same as f of t. Always. For all t's in the domain of f, the smallest number c for which that is f is periodic is called the period of c of f. The smallest number that sine and cosine can be, and they always be true, is 2 pi. 4 pi, 8 pi, 10 pi, all those work, but 2 pi is the smallest, so that's the period. We know that, okay, that's periodic functions, okay. Now, whoa, we're almost out of time, aren't we? Let's get this one in. Now, back in algebra, you learned what even and odd functions were. Okay, I don't know if you remember it. Here is the test. The test is to put in, instead of your independent variable, negate it. So if you know what f of t is, then plug in f of minus t. If that comes out being the same as f of t, that means it's an even function. If you put in a 1, you get this. Put in a negative 1, you get that. If for every value you get that, that's an even function. Okay? But it's an odd when you put in a minus t, so you go minus here. If f of t is up here, f of minus t is the opposite of it. That's an odd function. Okay? Now, back in algebra, I don't know if you remember this or not, most functions were neither functions, neither even nor odd. However, trig functions, because of the very nature, they tend to either be even or odd without many neithers. Now, you can make them neither, but most of the time they're not. So, which ones that whatever you do to this is the same as that? Well, let's see. When the x value is the same on both sides, okay, that would be an even function, okay? Well, where are the x's the same? Cosine of t is your x value, and secant of t would be your minus x values, okay? Well, if they're the same, then those are your even functions. The other 4 sine that have y's in them, sine, cosecant, tangent, and cotangent, those are odd functions because they're the other. So, you know, right here off the top, 2 of your trig functions are even, cosine and secant. The other 4 are all odds. Basically, the basic trig functions, none of them are neither. They're either even or odd. 2 being even, 4 being odd. Okay? Does that make sense? Okay. Don't think we're going to have time for example 2, so that's what we'll pick up next time. A lot of blah, blah, blah in this section. Sorry about that. Okay. So we'll pick up example 2 next time. Now, homework exercises here. Ooh, we came close to finishing 4.2, folks. Do either 5 or 7 or both. Do either 9 or 11 or both. Do any of the odds 13 to 21. Do any of the odds 23 to 29. Do any of the odds 31 to 35? Do any of the odds, let's see. I think you can stop at 35. We'll pick up the rest of those next time. Okay? Good deal. Any questions? Huh? This is 4.2. Yeah. And all those homework exercises were on page 277. So we'll pick up with example 2 next time. All right, good deal.